Hello, everyone. In this lecture, we're going to be talking about stock valuation. You're going to be able to calculate the value of a stock in the future. So, again, another very powerful skill for you to have that predictive ability with some very simple inputs to be able to calculate what the price of a stock is in the future. We are going to be using something called the constant growth model. And with that will come an assumption that the stock is going to constantly grow, which is pretty much the normal case anyway, you would hope, with any stock that you have. So here's what I want you to do with this particular lecture, though. I want you, encourage you to follow along with me. Have a piece of paper and a pencil and kind of be writing it down with me as you're going. I think that will help in your understanding of this as I'm going to work through a very common problem with simple inputs that you can easily get. Like today, you'll be able to apply this process to a stock today if you wish, and project its value somewhere out in time at really X number of years. Be careful though. The further you go out in time, the more uncertainty you introduce into anything in life. Like, God only knows where we're all going to be 10 years from now. God only knows what's going to be a stock price in 10 years from now. But you will be able to at least come up with a number after following today's exercise. All right, well, let's jump into the blackboard and work through some problems.
Okay, let's get the intimidating part out first. And then I think I'm going to attempt to put this in English so it looks like something that you can do. And I think once we do that, hopefully the intimidation factor will go away. But when we look at the actual constant growth model, let's get this part out of the way and then we'll simplify it. And you can also find this within your text. But you have the stock price, which is listed as this, equals the dividend in time 0 times 1 plus the expected growth rate. Wow, this is getting complicated. Divided by the required rate of return, the old RR, on equity, got a little E on there, minus that expected growth rate again. Okay? Well, let's go ahead and put this in English, and then we're going to work through a problem, and I think you'll find it won't be as intimidating as it appears. We're going to rewrite this, and let's put it in English. We've got stock price, and that's always what I like to do with formulas. I like to take away all the subscripts and actually write it in English a few times. Then you might find the abbreviations easier to work with, but I always start with the longhand version first. Okay, and we do have a division in here, so we're going to write that. We've got dividend, and that's the now dividend, the dividend we know, times, in a parentheses, a 1, that's not too intimidating, plus the expected growth rate. Whoops. That's an O, that's a W, expected growth rate, and put a parentheses on that. And that's going to be divided by, I will do a little bit of abbreviation here, that's required rate of return. We know what that is, right guys? You know what required rate of return is. It's that return of similar investments of similar risk. I think you've got that one down. Minus expected growth rate again. I am gonna abbreviate a little bit. Expected because I'm running out of space on my iPad. So expected growth rate. Okay. Hopefully this helps. Now we're going to just simply use this to solve for various pieces of it. And the most common one is we're going to work through a problem. I think the most common one, and really the one I want you to be able to do with using this constant growth model, and that's what this is. Up here, this is the constant growth model. We've just rephrased that in a little bit easier to understand format. At least that's easier for me. Okay, but this is the constant growth model right there. Let's put a little line, make some red right there. Okay, so that's our constant growth model. So what we're going to do now is we're going to actually kind of work through a problem. I think that would be realistic, what you'd see kind of in the, I guess, real world. So we're going to have a health system. We'll call it, well, I'll just make something up here. We'll call it, just USA health system. Health system and USA health system. We're going to know some things about USA, and we're going to know their stock price easily. You can find it, right? Go to the internet. Boom, it's there. Nobody looks at the newspaper anymore, but it used to be in the newspaper. I'm not sure if they still do that or not. All right, so the stock price we know is, let's say, $40. And we know that it pays a dividend or just paid a dividend. Again, this is all something you can find of $3. Okay? We know that for similar investments of similar risk, what does that sound like? Required rate of return. So that would be something pretty easily that we could lay our hands upon. With a little basic research, we could find the required rate of return for something of similar risk. Maybe we use the stock market's beta. Maybe we use the beta of the stock. Might work. Beta is actually published. I know we've worked on calculations of it, but you can actually find that published. No need to calculate. So you've got the required rate of return. And we'll say that's 10%. Okay, and we are going to assume the constant growth model. Okay, so we'll just assume that it's constant growth. There could be some occasions where maybe you would not be looking at constant growth, but again, the most common is you're going to be assuming a stock is going to continue to grow. It's going to be a going concern. You remember that from accounting, going concern. It's going to stay in business and grow. All right, so these are some pretty common inputs. We're going to plug these into our constant growth model right up there, and let's see what we get. All right, so first, let's see, what do we know? All right, we know the stock price. So we got $40. Okay, I'll start off with making number signs, but I'll probably stop doing that after a while. So we've got $40. Dividend. Yeah, we know that. $3. Okay. We got I'm just sticking my multiplication in here. We got a parentheses. We got a 1. We got a plus expected growth rate. Yeah, we got to find what's that. Huh. We don't have expected growth rate. We've got required rate of return, which we'll be using in just a few minutes for this item right here, but we don't know that. So let's just go ahead and, well, let's leave in a filler. Let's put in a filler. So I'm going to abbreviate, and I'm going to use expected, and I'll put a G in there for expected growth rate. Look familiar? That's what we had on our first intimidating formula. But we're going to use that, that E and G on there, expected growth rate. We're going to put our little line in here. We're going to plug in our required rate of return. We know that, 10%. And, oh, another mystery. Minus that expected growth rate. Don't know. Okay, well, let's solve for that expected growth rate. Boom. Can you do that? Well, it actually is. That part's a little complicated. What we're going to do here, I'm going to walk you through some algebra. Somewhat fundamental. Once you see the steps, I think you're going to be okay with that. But I'm going to move to another slide so we could have plenty of room to kind of work through that. But what I forgot is kind of why are we all doing this? Let's assume that what we're trying to find eventually is what is the stock price in 5 years. Okay, and I think you can kind of remember, think about going back to our first few chapters and modules with time value of money. We've got a lump sum, we've got a time frame, but we don't know what we called that I, or that interest rate. We don't know that. Well, actually, expected growth rate and the interest rate is going to be the same. That compounding rate is going to be the same. So we're going to end all of this with an old friend of yours that comes back from our time value of money chapter. All right, well, let's go ahead and break this down, and I think you'll find it, again, once you kind of go through the steps, it's not too difficult. All right, let's break this down using some of our old friends' algebra. And as I go through this, remember that when we're dealing with these formulas, okay, we've got, and that's what this is. It's the constant growth formula. We got to do things on both sides of the equation. And if you remember how to solve an equation, we have to kind of isolate the unknown to solve it. And the unknown in this case is that EG, okay, that expected growth rate. We have to find that. And then we'll tie it all back together here in the end. But let's find what this EG is. Best way to do that right now is we're going to need to get rid of this fraction. That's hard to deal with right over here. We need to get rid of this fraction right here. So let's go ahead and do that. Let me just bring this down here. I'm going to leave the dollar signs off just for clarity right now, but you know what they are. And that's actually a times. That's our times right there. So 1 plus EG, okay, over 10, that was that expected rate of return, and then EG. Okay. Well, to get rid of that, we have to get rid of what I'm pointing to. You can't see, but to get rid of the denominator down here, we have to multiply it times its inverse. The inverse of this is going to be 10% minus EG over 1. And we're going to do the same thing over here. Okay, and these are going to be multiplied. The wonderful thing with fractions, this great little algebra trick, is once that happens, these cancel out. So now we're left with 3 times 1 expected growth rate. On the other side, not so much. We have to do a little bit of math here. So, and that's a poorly written percentage. That's a percent, not a times. So we need to multiply 40 times 10% and 40 times EG. Well, if you remember, what's 10% of 40? Think of it, if you were leaving a tip, by the way, don't ever leave a 10% tip. At least tip your servers 20%. But if you were to leave a 10% tip and your bill came to $40, well, you could probably do that in your head, right? That's $4. If you couldn't do it in your head, you could use a calculator. And remember that 10% is also written in the math world as 0.10. Okay, times 40, you get $4. Okay, so we got that part. So we multiply that and we get $4, but I'll leave the dollar sign off. Minus 40 EG, because we don't know what EG is, okay? But now let's clean this up a little bit more. Let's go ahead and take care of this business right here. Which we can do. We can multiply that out now. So 3 times 1 is 3. And 3 times EG is 3. 3 EG. Okay, expected growth rate. All right, so we've cleaned that up even more. We are getting close here, guys. Very close. Okay? So I think you can see our next problem is we need to isolate the unknown to one side of the equation to solve. Again, if you're going back to that old algebra days. And that's very easy. Remember, we just have to add to each side of the equation. And so let's get rid of this. Let's focus on the negatives. You don't like the negatives on one side, so let's get rid of that. Let's get rid of that negative 40 EG or minus 40 EG right here. So how would we get rid of that? Add 40 EG to both sides. If we do that, and I'll just on the margin here, I'll just put we're adding 40 EG to each side. And that will bring this to, we just simply now have 4 equals 3 plus 43 EG. Well, we're almost there. Now, let's move on and get the unknown. That's a pretty sloppy EG there. Okay, EG, 43 EG, that's what that's supposed to say. Let's get that by itself. It's positive, we like that. Let's get it by itself. What do we need to do? We'll just minus 3 on each side of the equation. Some magic will happen. Of course, that 3 right here is going to go away. That guy is going to go away. So we're just going to be left with 43 expected times the expected growth rate. And 4 minus 3 is 1. Now I think you can get this from this point. It's pretty easy too. We've just got to get rid of that 43 now, and then we'll know what EG is. Remember that little trick that we used way back up here, just multiplying times the inverse. And in this case, it's going to be the 1 over 43. Multiply it on this side, on this side right here. The amazing thing that happens when you multiply that inverse times that is it goes away. So we're left with just EG and 1 divided by 43. Well, let's run the math on that. 1 divided by 43, and running my calculator here, and we are going to get 0.023 equals expected growth rate. What is this? Well, it's a percentage, remember? We're doing expected growth rate as we've been going all the way through. And what is 0.023? Remember, if 0.01 right up here is 10%, well, this is going to be simply 2.3%. So you've calculated the expected growth rate. Not quite done yet. Let me show you what, we're down the home stretch. Let me show you what we're going to do with that. Okay, we know our EG, expected growth rate, is 2.3%. Way back at the slide, hopefully you're writing this down on a piece of paper as you're going through. Watching me do it, you're doing it too. The stock price was $40. And what we want to know is what will be the stock price in 5 years. Well, we've got expected growth rate. Wait a minute, this looks familiar, doesn't it? We've got a present value, we have an I, an interest rate, and we have a number of periods. So you could go back, there's a couple ways you could solve this. I'm going to show you one. I'm going to jump on another system and show you how we do that on that arachnoid calculator. You can also solve it by this. If you're pretty good with your calculator, you can do it this way too. It'll work out the same difference. But basically the stock price, which, oh, that's a terrible, let me erase that. The stock price in any given year, that can be 5 years, 10 years, whatever. In this case, it's 5 years, is going to equal the present value, which we know, 40, times 1 plus the growth rate, which we can just write as 1.023. Don't forget how to write that. Always catches me and catches a lot of students that 2% is not written 0.2, or 23 in this case. That would actually be 23%. It's written as 0.023. And the exponent right here, that exponent is really the number of years. In this case, so x, I'll call it x. In this case, it's 5. So that would be the exponent of 5. So if you have a nice little handy-dandy calculator where you can enter in 1.023, if you have a calculator like an iPhone, it looks like this. It's like it gives you like an X and a Y. So you simply enter this number in, and then you hit the XY button, and then you hit the next number, which is the exponent, and boop, it'll calculate it for you. And then you'll simply multiply that number times the present value of 40. So you can do it that way if you want to get fancy with exponents, or you can do it the familiar way, which I'll show you in just a second, that we do with the arachnoid calculator. I just did this with the standard calculator here, and I got our stock price in 5 years. Let's try to write a little bit better here. Okay, stock price in 5 years to equal $44.82. Now, there's also something else that usually throws people, and a little bit of a thought question here. So I'll tell you what, here's what we'll do. I'll throw this out as extra credit. So if you're watching the lectures, and here you go, and you can solve this, and this is going to be one of the, you gotta give me the correct answer why this is the case, but you can just think about it. I'll give you maybe a little bit of a hint, but we've got the expected growth rate of 2.3%. If you remember, when we started this whole thing off, we had a required rate of return of 10%. Now, why is it that we have a required, we think that, well, wait a minute, I have a required rate of return of 10. Why is my expected growth rate on this stock only 2.3%? So if you can give me the answer of why that growth rate is only 2.3, we're missing something here. There's something in this right here, in this stock price, we are missing. So think about, when you think about a stock, when you look to buy a stock, there are many things, a few key things, maybe only two things. I'll give you that hint. There are generally two things in a stock that you are basically weighing, that you're assessing to determine its value. Okay? Stock price now and what you think it is in the future is one. But there's another piece in there that we use to value a stock. So think about that. So here's what we'll do. If you, I guess we'll do this as an email. So you email me what you think that might be, and I will let you know. But again, you got to get it exactly right. What is the thing that we're missing here? Because this actually, the math works. We're missing something, which is fine, but it's okay with this because we were only calculating stock price. So what is it other than stock price that helps us value a stock? And we'll say, all right, this extra credit will be worth, this is a good conceptual question. This will be worth 10 points. Okay? So if you email me what we're not thinking about here with the stock price to basically that we're not accounting for in this required rate of return of 10%, you'll get 10 points. Okay, let's jump into the arachnoid calculator to show you those calculations, kind of the easy way on how to get to that 4482.
All right, well, let's wind this up by calculating that future value from that present value. This should be pretty easy stuff for you. So now that we went through all of the hard work, all right, let's go ahead and fill this out. What we do know, we know the present value, that was that stock price of the now, which was 40. Future value, we don't know. Number of periods, we know. We're trying to understand what that stock price is in 5 years. Payment amount. Okay, well, that's not applicable because we're just concerned about the stock. Okay, the stock itself. And the interest rate, well, that's why we went through all that pain, all those calculations that we did. Again, somewhat simple, but just make sure you work through them with a little bit of attention to detail, and you should be just fine. But we got, and this one is written in a percentage. You can tell right here because the nice person at Arachnoid who did the programming actually put a little percentage in there. So we're going to write that as a percentage. So we go back to that, not the decimal form. We go back to the 2.3 percent is what we got, and we cross our fingers. And oh, I better put a negative in here. I just have a feeling that's gonna, yeah, there we go, yep. And if I didn't, remember, if it came out to a negative, you would know to change that. But let's cross our fingers, hit future value, ta-da! And there we go. 44.82 would be that stock price in 5 years. All right, so now you know how to do this. Another amazing skill that you can add to that very few people, when you look at the population, and very few people in business, would have this understanding as far as valuation of stock price. And this can be very important for you, both as a manager, if you work for a profit entity. If you're a nonprofit, well, I can tell you the nonprofit that I work for owns a lot of securities that, either through trusts or regular investments on the financial side. They have cash. And when you have surplus cash, a savvy CFO is going to be investing a portion of that may not be super risky items, but they're going to be investing a portion of that. I know we have millions and millions and millions and millions of dollars invested in the market, and actually that has impacted from our nonprofit side. When the market has gone down in recent years, which it did back during the Great Recession, that impacted our ability here at the nonprofit I work for, a major nonprofit health system, and our ability because to even purchase our capital was limited. So it's like, no, you can't buy anything this year because our financial investments have tanked. So a lot of major projects were put on hold because of that. So even nonprofits are not immune to this effect. And this is also, again, an essential tool. And now here's another thing too. You might hear on TV or you read on the internet or maybe you catch something on the radio about XYZ company has revised their earnings statements or XYZ company has cut their dividend. And the market goes nuts when that happens because all of these calculations are based on information that they were given. The investors, the individual investors are given, and now the company has revised something. They've cut the dividend. You were expecting a dividend of $3, and now it's not going to be that anymore. It's going to be $1. And think about it, you as an investor, if you bought a company and all of a sudden they were you paid a price for that company, that stock, you paid a price for that, and you thought that's a fair price based on what I expect to get out of it. And if something happened to that company and you didn't get to what you expected, that's when you see the price tank. Or in the opposite, when a company says, out of the blue, we're increasing the dividend by XYZ, you see the price go right up. So now you got a little understanding about how that can impact those stock valuations from a calculation standpoint, and you know how to do this. So pat yourself on the back. Another very unique skill that you can add to your toolkit of financial literacy.